All right, so yesterday we made our pH foldable, and I told you I wanted you to look for the big picture, which was when we change from one pH to the other, what happens to the concentration of our hydrogen? How does that change? Now, what I hope you've noticed is that a change of 1 in pH is a change of 10 in the concentration. So look at this, 1 times 10 to the negative 11th, okay, versus 1 times 10 to the negative 10th. So really all we're doing is moving that decimal one place over. So every change in pH is a change in 10 times the magnitude of the hydrogen concentration, okay? So hydrogen concentration is going to be what determines our pH. Now another thing I want you guys to notice is, look at these exponents. Hydrogen concentration of negative 14 is a pH of 14. Negative 13, 13. 12, 12. 11, 11. 10, 10. 9, 9. 8, etc. It goes all the way down like that. So we can actually use our exponent to estimate where our pH is going to end up. Okay, so it's kind of cool actually. So we're going to do some pH calculations today. This is going to involve learning how to use a new button on your calculator that you may never have used it before, and that's cool. So what's in this little box, you might want to pause the video and write down in your notes.
Good morning, Calta. If you are AP Spanish language testing this morning, please go to Gym 2. We are beginning our testing this morning. Also, this message goes out to seniors. If you have not yet turned in your Chromebook, you need to do so today during first and second period at your teacher's discretion. The library will be closed for that after testing today. Have a great day, Buffalo.
Sorry for the interruption. All right, so you might want to go ahead and write down this box. To calculate the pH of any solution, you take the negative log of the molarity of the H plus ions. And here's our little equation. pH is equal to the negative log of H plus. So, first of all, I want to show you where that button is. All right, on your calculator, we have several different buttons. This is kind of hard to see with the glare. There we go. So, it's better. Down here, right next to the 7, is your log button, okay? And that is that times 10 relationship button. So let's go ahead and do this first one. They've given us a hydrogen concentration of 1.0 times 10 to the minus 1, and they've asked us to find the pH. So we're going to take the negative log, and you'll notice that it automatically opens up a parentheses for you, okay? And then we're going to put in this number. Now remember, we're going to use our special buttons here. We're going to use 1.0 second, comma, negative 1. So it should look like that on your screen, 1.0 e negative 1. And then close off that parentheses. That gets us a pH of 1. Now if you look at this exponent here, that's what we would expect, because usually our exponent matches our pH. So let's do this next one. We're going to take the negative log of 1.0 second, comma, negative 14. Close off that parentheses. That gets us a pH of 14. And again, if we look at our exponent, 14 should be at 14. All right, so 1.0 second, comma, negative 3, negative log of 1.0 second, comma, negative 3. What are we thinking? What are we thinking? Are we thinking 3? Because that's the answer. Okay, and look, our exponent matches our pH. Okay, so let's do this next one. Negative log of 1.0 second, comma, negative 11. That gets us a pH of 11. So here they match. All right. Now, so far, we've only stuck to H concentrations that are a 1. And we can predict this one over here. If it's times 10 to the negative 5th, that's going to be a pH of 5. Times 10 to the negative 9th, that's going to be a pH of 9. Times 10 to the minus 7th, that's going to be a pH of 7. Okay? So, is there any pattern or repeating trend that emerges? What is it? The exponent is the negative pH value when the number is 1.0. Okay, so 1.0 times 10 to the x. Your exponent is the negative pH value when the number is a 1.0. So now this second section, we're going to predict pH values from our concentration, but look. No longer is it 1. Not 1 anymore. So this is going to mean that we're not going to get perfect numbers. They're going to be close to that number, but they're not going to be perfect. So we're going to use our exponent to predict the value. Then we're actually going to calculate it with the negative log. So this first one, 4.56 times 10 to the minus 1, we would predict, based on that exponent, that it should be close to a pH of 1. Now, let's actually calculate it. So we're going to take the negative log of 4.56 second comma negative 1. That actually gets us a pH of 0.34. So I want to point out what happened. This number became greater than 1. It's higher than 1. And that drove the pH lower than our prediction. So the higher this number is, the lower our pH is going to be from the predicted value. Okay? So let's apply that here. We have times 10 to the negative 14th. We would predict that it's going to be around 14. This number is higher than 1, so we're going to say that it's going to be a little bit less than 14. Okay? So now let's actually calculate it. We have the negative log of 2.32 second comma negative 14. And look at that, 13.6, just under 14. So our actual value is 13.6. That makes perfect sense because of where our exponent is and where our number was. It was slightly greater than 1, not nearly as big as this number. So you'll notice that it didn't affect it quite as much. We had a much closer number this time. Let's do one more of these. 3.10 times 10 to the negative 3. That negative 3 tells us our pH should be around 3. We're a little bit higher than 1, so we're going to say this is going to be just under 3. All right, so now let's calculate it. Negative log of 3.11 second comma negative 3 gives us 2.5. We're like right there in the middle, halfway between 2 and 3. Let's do one more of these. We have 9.45. Wow, that's huge. Okay, times 10 to the negative 11th. Now, since this one is really close to 10, that means that we're close to our next value. So remember, the higher this number is, the lower it's going to be from our predicted. So our predicted would be 11, but we're going to actually say that this is going to be slightly greater than 10 because we're so close to a 10 here, and the next pH lower than 11 would be the 10. So now let's plug her in. We have the negative log of 9.45 second comma negative 11. And look at that, we're right at 10.02. So just a little bit above 10. Okay, so the closer this number is to 1, the more closely our number will be related to, our pH value will be related to this exponent. The higher this number goes, the closer it is to the number below it. Okay, so it's going to drive our number down. Okay, so the closer the number was to 10, the further the pH is from the prediction. The closer the number is to 1, the closer the pH is to the prediction. Okay, the closer the number was to 10, the closer the pH was to the number below the prediction. The closer the number was to 1, the closer the pH was to my prediction. Okay, so we probably want to have those things written down. All right, so the next thing we want to talk about is, what if I know the pH? Because I can actually measure pH using pH paper or using indicators or things like that. And I can actually go the other direction and use it to figure out what the concentration of hydrogen is. That's actually really useful in terms of figuring out how acidic your acid is. So when a compound beginning in H is dissolved in water, it typically ionizes, resulting in the formation of H+ ions in the water. It is the concentration of the H+ ions that we need in order to determine the pH. The concentration of the solution can be used to determine the concentration of H+ ions. If one molecule of HCl breaks apart into ions, it will result in one H plus ion and one Cl minus ion. If two molecules of HCl break apart into ions, it will result in two H plus ions and two Cl minus ions. Because there's only one H plus breaking away, the concentration of H plus is equal to whatever the concentration of the acidic solution is. All right, so write down that sentence. The concentration of H plus is equal to whatever the concentration of the acidic solution is. Okay, and here's a picture of it. You might want to draw this picture in your notes as well. Okay, one molecule of HCl, you dissolve it in water, it breaks apart into a Cl and an H plus. All right, so here they've given us the concentration of acidic solution, and they've asked us for the concentration of H plus and then the pH. So what I'm going to do is I'm going to say, okay, in this one there's one hydrogen for every one chlorine, so this concentration is going to be the same as my concentration of H plus. So to get my pH, I'm going to take the negative log of 3.4 times 10 to the minus 4th. And that gets me 3.5 as my pH. So for this one, I have 9.1 times 10 to the second molar HBr. So when that's just H plus, that's still going to be 9.1 times 10 to the minus second molar H plus. So we're going to take the negative log of 9.1 second, comma, negative 2. That's going to get us 1.04 as our pH of solution. All right. So the last thing I want to show you is going back the other way. So how do I get from pH to my H plus concentration? Okay, so we're going to do what's called the inverse log. Okay, so 10 to the negative pH is going to be equal to our concentration of H plus. All right, so now on your calculator, what we're going to do is we're going to hit second function and then the log button. And you're going to get a little 10 to the, and then a little box. We're going to put in our negative pH there, 10 to the negative pH. So let's say we had a pH of 4.5. So I would do 10 to the negative 4.5, and that's going to get me an H plus concentration of 3.16 times 10 to the minus 5th molar. All right, let's say we have a pH equals 2.4. Okay, so our H plus is going to be equal to 10 to the power of negative 2.4. So we're going to do second log negative 2.4, enter. That gets us 0.00398 molar. Or we could write that as 3.98 times 10 to the minus 3rd molar. Okay, let's do one more of those and then we'll be done for today. Let's say we have a pH of 11.6. Our H plus concentration is going to be equal to 10 to the power of negative 11.6. So second log negative 11.6 gives us 2.5 times 10 to the negative 12. And again, check your number, 11.6, negative 12. They should be really close. Okay, 2.4, 3.98. Okay, so your numbers and your exponents should be really close. Okay.